Hey, Nathan here from PH Studios, and welcome back to another Tower Defense Engine tutorial. In this tutorial, we're going to discuss the MapRegion class. And just like the last tutorial, the command info bar, the code is complete, and I'm just going to discuss a few things of interest in here. That way I don't have to create a 2-hour long video just for one class. Okay, so the properties are all finished. We did that in part 1. Part 2, where we fill in the method bodies. The constructor, we need to set up the local reference to the session and rectangle that we pass it. And then we programmatically generate textures for the valid placement, invalid placement, and spawn placement. And we also do that for monster health display. So we programmatically generate 4 textures, so we need to use a graphics device for that. They're going to be 1 pixel by 1 pixel, that's what the 1,1 is for, and we set up the color. A valid placement is the map's forecolor. Invalid placement is the map's, or is red in this case. Spawn placement is blue. Monster health display is the forecolor of the map as well. So we have to generate a color array and set all this stuff up, and then when we create a new texture, we need to call .setData, tell it we need to give it a color array, and we pass it the color array to use. Okay, now we sign ourselves up for tower purchase and tower sold events, and we use these methods here. So whenever we sell a tower, we need to set the selected active tower to null. And we get the selected active tower from the tower sold is PTEA. We get that from the PTEA, and if they're equal, we need to set it to null, because we selected the tower, we sold the tower. If that tower that we have selected has been sold, we don't have a tower to select anymore. Okay, if the tower is purchased, we need to sign up for the left click event in this class here. And we get the tower's object from the PTEA as well. So when that tower is a left click, we will be notified in the left click event method, which is right here. So the tower is sent by the object sender, so we do use the word as. That's kind of an advanced cast. I did a tutorial on that from my Advanced Techniques series. It casts it, and if it is not a tower, it'll set it to null. So tower T, we get that as a tower, and if the place time is greater than 1, we set it as the selected active tower. Now this is used for a delay. When you click to place a tower, remember, the program is so fast that if I did not have this delay in there, as soon as I clicked to place the tower, it would have already selected it. And we don't want that to happen. So we have some sort of delay. If it's placed for more than 1 second, then we can select it. And you can extend the engine if you want to. If you want to have this like 5 seconds and have an actual build animation. And that's pretty simple to do. You just have states. You have tower states. As soon as it's placed, it's set to the build state. And then you have you can use my animation class and have a texture, a sprite sheet for the build animation. And that will last for 5 seconds or however long you want to set it. And after that 5 seconds, you change the tower state to placed. So there's an easy advantage here to increasing this to using states or just 5 seconds and having a initial build animation. So it looks like the tower is being built instead of immediately there. Okay, now to update the map region, we check to see if the mouse is new left clicked and if the rectangle, which is the rectangle of the region, intersects with our mouse rectangle. So our mouse is inside the region, our map region, and we have left clicked. It's a new left click. And if the selection.selected tower is not null. Once we do all that, we get the mouse pointer in map. We convert our mouse pointer's position to map coordinates, and then we can see if it's a valid placement. Then we purchase the tower. So how do we know we're in a purchase tower mode? That's what this is for. We have a selected tower object. If the session.selected tower is not null, that means we want to place a tower. We're in a purchase tower mode. We clicked the buy the tower button. That sets the selected tower to the tower we want to purchase. So if that is not null, we are in a purchase a tower mode. And we have clicked, we are in the map region, we check to see if it's a valid placement. If it is, we purchase the tower and deselect it. And we clone it. We clone the tower, so we get a fresh object of the tower, and it's being sent to the mouse pointer in map. Okay, now drawing is pretty simple, just like any tile drawing. If you want to get a more detailed look on how to draw tiles, check out my maps tutorial, 3-part tutorial series on how to display maps. But we have a tile code and an integer, and we do a for loop for every y and x coordinate in the map. We get the tile code by looking at the ground tiles first. Now, we are using both x and y here, and we need to convert that to a single dimensional array. To do that, we multiply y times the map's dimensions.x plus x. That will convert it from a multi-dimensional input, x and y, to a one-dimensional array. So we get the tile code for that. Now the tile code can be 1 or 2 or 3, or let me open up the game here and show you. So we have a map, and that's in textures. So let's look at the maps here. Alright, so the tile code, these are the ground tiles. The tile code can be 0, 1, or it can be 11, 7, 8, 6, and all that stuff. That's the tile code. So we get the tile code, and then we get the integer tile code y, and we take the tile code divided by the number of tiles in sheet.x, and then we get the tile code x, and that's the tile code minus tile code y times number of tiles in sheet.x. So what this is doing here, it's getting the x and y of the specific tile we need to draw. So if we go back to our finished game, and let me go ahead and resize this window really quick. Just 1 second. So we have a content, and in our textures, we have a map. And the map, let's look at the vector map. The vector map has a tiles image. So we have a tile code. Let's say it's 1, 2, 3, 4, 5, 6. So this will be 6. So we need to get the x and y for that tile in the sheet. And that's what that code is doing. We have a tile code. Let's say it's 6. We need to get the y coordinate and x coordinate for in the sheet. So 6 divided by the number of tiles in sheets, 5. That will give us a y coordinate. 6 divided by 5, that will be 1. It's doing integer division here, so it's not going to be 1.045 or 1.1 or anything like that. It's going to be 6 divided by 5, integer division, that's 1. So we go down 1 level. And that's correct, because we are down one row, and there's 6. Okay, so for the X, we have a tile code that's 6 in my example, and then the tile code Y coordinate, which is 1, which we got from the top line, times the number of tiles in sheet.x, that's 6. So 1 times 6 is 6. 6 minus 6 is 0. So we are down one row on the far left side of the texture sheet. So we have our desired start point. Okay, so now we draw that tile that we are looking at. So we have a tile sheet we get from the map. So map.tilesheet. New vector to x times the tile dimensions in x, comma, y times the number of tiles dimensions in y. That tells it the position to draw the tile. Okay, so now for the tricky part, to get to the actual part of the texture to draw. The tile that we want to draw from a tile sheet. We have the tile code x times the tile dimensions.x, comma, the tile code y times the tile dimensions.y, comma, 64 by 64. So we get the x and y starting point, and we multiply it by the tile dimensions x and the tile dimensions.y. And then every tile in my game is a 64 by 64, so I just hard-coded those values. Okay, so can any of you programmers tell me what is wrong with this for loop here? This is from version 1.0. It's not really an issue, it's just a redundant code. I fixed it in a patch, but this is version 1.0 that I'm developing for telling you how to develop. So I might as well talk about what this bug is. Again, it's not really an issue, it's just doing this multiple times when it only needs to do it once. We have two for loops here. We for in the y direction of the dimensions, and we for in the x dimension. So we have two for loops. We finish one for loop, and then we do another one here. Alright, now we finish that one, and we do the next one in the y direction. And then we do the other two as well. This code right here, that code does not use y or x. So I only need to do that code once. It doesn't need to be nested in another for loop, so I can cut that out and move it outside of the two for loops here. So what it was doing is it was drawing unnecessary data because it was doing it 10 or 20 times in the y for loop. It was doing this 10 or 20 times. And it's a simple mistake. When I was just programming it, I just ended the for loop. I thought I ended it twice, and I just generated another for loop like that. And I caught it in a later patch, and it's fixed. But I thought I would demonstrate one of the issues I had. So like I said, it was not causing anything at all. It was running the game just fine. The only thing it would have caused was your code would take longer to finish, because it was doing this multiple times when it only had to do it once. Alright, so now let's talk about what that for loop does. It generates the shortest path. And that shortest path is for the monster path. So it generates the monster's path, which is in the forest map, for example. It's that dirt-looking tile. And that's what that generates here. Okay. For every monster in our active wave.monsters list, we need to draw the monster, and we need to draw the monster's health display. So for every monster, it will draw its own health display. And it will generate it based on the monster's health divided by the monster's maximum health. And it's going to be a float, so we can scale the health bar however we want it. So it's a nice and smooth transition. If you want to take this a step farther, you can change the color depending on its health. If it's 100%, it's green. If it's 0 or a little bit before 0, it's red. And just, in between yellow, orange, red, and all that stuff, like some games do. Now we draw the spawn and the castle. And if we have a tower selected, we draw its radius. Now we draw the radius before we draw the towers, so the towers are above the radius. So now we do a for each and draw every tower in our placed towers list. If we have a tower selected, we are in purchase a tower mode, and we need to draw the placeable array. If you play the game and you click buy a tower and move your mouse to the map region, it will draw the placeable locations. Where you can place it will be in green. Where you cannot place it will be in red. Where the spawn location is will be in blue. So to draw that overlay at 50% opacity, and it will draw those so we can get a nice visual. Hey, I can place it here, I can't place it here, and this is where the monsters come from. So we check to see if the X and Y is a valid placement. If it is, we draw the valid placement texture, which is just the map's forecolor, typically green in the forest map, for example. If it is not a valid placement, that means it is either the spawn location or just a standard invalid placement. To test to see if it's a spawn location, you need to test to see the spawn location.x and spawn location.y. Now we need to get a mouse pointer in map. We need to convert our mouse position to map coordinates. And then we also need to get the mouse pointer in world. So we convert that back to world coordinates. And then we see if is valid placement mouse pointer in map X and Y. And then we draw the selected tower texture. Alright, so let me demonstrate what I'm discussing here. When we click buy a tower, we are in purchase a tower mode. And that point is going to display that overlay. The forecolor is where I can place a tower. So in this map, it's green. Where I cannot place a tower, it's in red. And the spawn location is in blue. Now at the very end of that loop, we converted the mouse pointer to map coordinates and reconverted that back to world coordinates. So if the mouse pointer is in a valid placement, we need to draw the tower at 50% opacity. As you see, as I'm moving my mouse over here, it's actually displaying the tower at 50% opacity. When I hover over it on the red tiles, it does not do anything. Same with the blue tiles. They are invalid placements. So that's what that whole map region does. It displays our map tiles depending on the tile code. It gets to the appropriate position in the tile sheet. And then we display the user interface overlay on where we can place the towers if we're in a purchase tower mode. It displays all of our towers, the ones we have placed. It displays all of our monsters. It displays each monster gets its own health bar at the top. That's what this class does. And we have a reset tower references, and all that does is reset the selected active tower to null. Alright, so that is it for this class. Again, just like the last video, I will copy this class file and send it to you in the YouTube description. That way you do not need to code everything yourself from looking at my video. I'll give you the code, and I think I discussed it pretty well. If you have any questions about it, let me know. And we have one more video left, and that's the map class. So I hope to see you in that video.